Okay, now this exercise, I try to put as many as information as possible so we can try to study everything, okay? Now, the first information is the minus in here. Well, we have seen that when I put a minus, it means that every single point that was supposed to be positive for this x, okay, in here, that point for that x, it is positive. Because you have a negative, it's going to be reflected over the x-axis, and that point is going to be right in here. Let's take this point in here. For this x, it is this y, but y now is going to be negative, and so on. So we are just going to make, okay, the reflection over the x, and this is going to be just like that, okay? If we were to draw, it would be something like this, okay? It is the green curve in here. Now this two is just stretching, okay? And for that, I would like to go in here because I always like to make things more visual. Okay, or let's just stretch. Okay, now this is the tangent. Let's put, okay, a 2 in here. This is going to be our green curve. Okay, I'm just stretching. Now y equals maybe 3 tangents of x. You see, going even further. Let's just okay, get rid of this one. Now let's make y equals maybe 7 tangents of x. I'm just stretching more and more. Okay, what happens if I put 70? It's going to be very stretched. You see, very stretched. But something we have to account. Okay, this, it is going to infinite. Okay, when I just put pi over 2 in here, because remember the asymptote in here is pi over 2. When I just put pi over 2, it is going to infinite. Okay, it is going in a different speeds, but it is eventually this line, it is going to almost touch the asymptote, but very high. Okay, and that is what happens. Okay, let's not put 70, it's too much, let's just leave it 70. Okay, and now what happens on the contrary? Well, let's put y equals so 0.5 the tangent of x. You see, look, we are in here. You see, look, we are, it's this curve in here. It's just making more, the ballet is being more as more strong. Okay, now what about if I put less? Okay, maybe not this one, maybe this one, maybe 0.2. You see, more and more. Well, let's see another one, even a smaller number in here, 0.1. You see, okay, and remember that this one, it is our basic tangent. Okay, it is this equation in here. This one, it is number 6 in here, 0.5. This one, 0.2, 0.1. You see, so this is one, a big one in here. Okay, and what is it? Why is this important? It's very important because you don't have to do this by your hands, but maybe, okay, let's suppose that your teacher just gives you this. Okay, it would be a wonderful exercise. It just gives you all those equations, and you just have this plot, exactly a plot like this. Okay, and you can't see anything else. We just have this plot in here, and you have to say which is which. Well, you don't have to know to draw by hand, by free hand, but you have to understand this. The higher it is this number in here, the higher this number, okay, this inclination, it must be higher, because the higher it is, we are stretching more the curve, and the lower it is, it must be this one. Okay, so you just have the normal order. So you can do this, okay, if it's being asked. Now, the period, you know, the period is just, okay, shrinking like this. The more we shrink, the more curves you have per length in here. No, nothing new in here. Now, the phase shift, okay, the phase shift, this is going to be the phase shift. Those two in here. This is going to be the direction. When it's a plus, it is to the left, it is the opposite, okay? And this goes for the sine, cosine, and tangent. And when it's negative, we go to the right, okay? So a negative signal means we have a right phase shift. A positive right here, we have a left. So our case is this one, right? Left phase shift. And what have I made in here now? Well, just ignore this part, okay? Ignore totally this part. You can't see it. Okay. So just think about this. What have I done in here? Well, this gives the direction and this gives the magnitude. If we just take those two information, okay, because we have three informations we have to account for. 1, 2, 3. Let's take one by one. If we just take this information along with that, it means that I'm going to have a left because of this shift, and that left will have a magnitude of pi over 2. So taking those two informations, we're going to have a left pi over 2 phase shift. Is that all? No, it's not all, because this will also account for this change. Now is that it comes everything. Now, if we take this information, look, that is the pink line here. If we account this information and we connect this information with this other one, okay, which is the left pi over 2, we are going to have a left pi over 4. You see, you have to sum all the information that it is brought to us. Separately, this is magnitude. Separately, this is only the direction. And separately, this is only the period change. When we start to aggregate them together, we can see that we initially had a left pi over 2 phase shift. It's correct, left pi over 2, goody. But we haven't acknowledged yet this information. Now, if you add this information in here to this information, okay, now it means that that left pi over 2 is going to be half that. Why? Because the period, it is being changed entirely, okay, by half. So what is the final phase shift we have to consider? We have to consider those three informations, okay? The pi over 2, the left pi over 2, and now pi over 4. And this is our left phase shift, okay? Good. Now let's start trying to chart it. Remember, one idea that we have to make our chart, it is starting by just make x equals 0. Let's try to pick a point in here, okay? Let's do it. If x equals 0, it's going to, what is going to be y? Minus 2 tangent of pi over 2. But pi over 2, it is infinite, okay? And because we have a negative here, it's going to be negative infinite. So our point should be when x equals 0, down here, right? But, well, when we go to infinity, it means that we are along this asymptote. Not along, we are not over the asymptote. We never reach the asymptote, but it's very close to it. But the problem is, we have, so by this, we have a point down here, okay? And when we have plus or minus infinite, it means that we are along this asymptote. But we don't know if we can know, but I'm going to explain the end of the video, okay? It's a little bit more advanced, but so far, okay, we don't know if it's going, the chart is going to be on this side or on this side, but it changes a lot, because when you have an asymptote, okay, we can have both ways. So what I'm trying to say is, it's kind of tricky, okay? It's better not to go in this way when you just follow in a position like this. Well, since we're not sure, okay, if we should draw the curve in here or in here, what should we do? There is another process that we can use, okay? Another way that you can use, it is just pick that point. Remember, let's take that point and transfer to this chart. But remember, we can only transfer the point which is along the y axis, okay? Because that point, it's the only point that we can only apply the phase shift, okay? Because remember, this point is not altered by the period change. Why? Because when we shrink something or expand, when x equals 0, it's nothing, okay? It's let's suppose we have 500 times x, or maybe x divided by 1000. When x equals 0, nothing happens. So this point in here, it is only going to be affected by the phase shift. And so what is this point? It's 0. So let's bring that point to this chart, and that's it. This is going to be our initial starting point, because that one, it could lead you to some mistakes, okay? So this is better to work in this case. Now, it's 0, isn't it? Well, we have a phase shift of minus pi over 4. Therefore, that point should be brought to here, okay? At a negative pi over 4. I just have placed, okay, those numbers. Okay, let's continue. So that point in here, it is going to be moved to the left. Why? Because it's a positive. So it's going to be a left, okay, phase shift. It's going to move pi over 4 because it is this pi over 2 divided by this 2, which is pi over 4. So that point, it is going to be that point in here, okay? So this is going to be our initial point. Now, we know that this is one asymptote, okay? If this is one asymptote, this one is symmetrical. This must be the other one, okay? So let's just try it. So at minus pi over 2, we are going to have one asymptote, okay? And at, okay, and this is going to be the other one, okay? We just have to be careful what we are doing. So this is going to be one asymptote, okay? The other one is going to be this one, okay? And that point is going to be this one. Therefore, how should be our chart? Our chart should be this. We are just going from infinity. Oh, now let's just be careful, okay? We know that our chart, it is going to be within this space in here, okay? It's going to be around here. Now the question is it going to be like this, or is it going to be like that? Now this is the question we have to answer. And to help you in here, let me do something here. Well, if we had a positive in here, we would have the exactly same chart, just ignoring, okay, the shrinking process. And so if we had a plus in here, it would be like this. Go, touch the root, and go down. But because it's negative, it's going to be the reverse, okay? So our chart is going to start in here, okay? It's going to be reverse of this. And therefore, just be careful, okay? This is where most people would make a mistake. And so we have this. Something like this. This is going to be our chart. Because of this negative, okay? Again, if we had a positive in here, we would draw the same pattern as in here. Starting from the right and going to the left, okay? And now we can draw all the other lines, okay? Just taking every pi over 2 is going to be another one. So this is an asymptote. The other asymptote would be in here at pi over 2. Let's just draw it. This would be the other asymptote. Okay, and now our chart is going to be the same as this one, okay? But now we're going to start in here. And something like this. And again, every pi over 2 we're going to do. And why every pi over 2? Something I didn't write. What is the period in here for this one? The period, it is just pi, okay? Now, what is going to be the period in here? The period for this equation, it's going to be this one divided by 2. Agree? It is just half of that. Well, this is the period, and that is why, and this is going to be the period in here. So this is going to be our pi okay? This is going to be our period, and this is going to be pi over 2, okay? From root to root, again, pi over 2. Now, once we have our periods, we know how to replicate that chart all the way. Okay, so this is another asymptote, and so on. So we can have many asymptotes as you wish for. Okay? Okay, and this is going to be the end, okay, of our charting. Like I said, it's always safe when we start. You just take that point and just apply the shift. That point is going to be this point, okay? And then we just apply the period or the half periods. It's much more simpler. Now, this is going to be a little bit different, okay? A different topic. And I'm not going to create a new video, but I'm just going to make it in the same way. If you're not interested, it's a little bit more advanced, okay? There is no need to follow, but okay. Remember when I told you that when we are trying to make the initial of this chart, we could put x equals 0, and for x equals 0, our y is going to be negative infinity. But we didn't know that if our curve, it would be negative infinity from this end or from this side. It changed a lot, because if the point is in here, this is going to be our curve. But if the minus infinity comes from this side, then the curve would be opposite. Totally different. Don't do this, okay? If you don't know, don't do it, okay? Just like I said, it's much more safer to work taking that point and making the phase shift to the left and applying this. But I promise you that it could be done, so I'm going to prove it. But it needs a little bit more advanced, okay, math. Not a very advanced math, but probably not the one we're going to study, at least not in a short while. Well, in math we have something that is limits, okay, and let's apply the limits to 0. So the limit of this equation minus, let me put even like this so you can see me writing. So the limit of 2 tangent of 2x plus pi over 2 when x goes to 0, but let's establish 0 from the positive side. We just put 0 plus, means we are going to 0, but we know that going from 0 from this side, it's going to be something. From the other side, it's going to be the opposite. You see? Look, the asymptote, when the function reaches the asymptote, it goes into two different positions, okay? So let's just study that. The limit of this function when x goes to 0 from the positive end, let's see. Well, what is x? It is 0, okay? 0, but it's 0 from the positive end, okay? So it means that we are going to have pi over 2. I'm just studying this in here, okay? Pi over 2 plus something very, 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 very tiny. 0, 0, 0, 0, 0, 0, 0, okay? 0, 0, 2. But it is still positive because we're going from the positive end. What does that mean? Well, let's go to our trigonometric circle. Okay, remember the tangent, it is this one, right? This is the tangent axis. Okay? Now, what does it mean when we have pi over 2 is here? Pi over 2 plus something very tiny. Well, we are on this end, okay? So maybe we are in here, okay? Look, what is the tangent of this angle in here? It's going to be what? Minus infinite, okay? So the tangent of this guy in here, when x goes to 0 from the positive end, this is going to be minus infinite. Minus infinite, with that minus, it is plus infinite. Okay? So the limit when the function goes to 0 from the positive side it is going to be plus infinite. So we know that when 0 goes from here to this 0, it is going to be positive. It's going to be this. Okay, so only by that we could already start to draw this. And therefore, when, let's make it the other way, when the limits, let's do this. So when the limits of this function, 2 tangent of 2x plus pi over 2, when x goes to 0 from the negative side, okay, that's what it means, that minus in here. What is that? Well, now negative sign, what does it mean? Let's study what's happening here. It's going to be pi over 2 minus something very tiny, okay, very tiny. But now we are not going to have bigger than 90 degrees, right? This is going to be bigger, okay, this is going to be bigger, this is going to be smaller than 90 degrees, okay, like 89.9999, but still smaller than 90 degrees. And again, this is tangent, okay, that line is tangent. What does that mean here? Pi over 2 minus something very tiny. Why? Because 0 is going to be very tiny, but very tiny subtracting from this guy. So it's going to be maybe in here, okay? And now what is going to be the tangent of that angle in here is going to be plus infinite. But remember, a plus infinite in here with that negative means a negative infinite. And that is why, okay, when x goes to 0, from the negative side, we are going to have a negative side, okay, and we are going to have negative infinite. Of course, you don't need to know that, okay, but just in case, okay, someone just get interested, okay, we could use this information with that to determine, okay, that this minus infinite is from this end in here, because from the positive end it is plus, okay, infinite. No need to know that, okay. The exercise stopped minutes ago. That is exercise, okay. It's not difficult, but it needs a lot of concentration, okay. So thank you very much, okay, and enjoy math. Math is so beautiful, but it needs concentration, calm, focus, and of course we need tools to understand what is going on, okay. And above all, we need patience to understand which goes which, okay. Thank you very much and good exam.